Hi everyone, Dankman here. Today we're going to introduce a new topic. Khan Academy calls it manipulating equations in order to do elimination. We'll see what we want to call it today, but the point is there's going to be one new level of complexity that we didn't see before. I'm matching today's video with a short handout. You do not have to print the handout at all, of course. As I've explained, we're not printing any handouts for the rest of this semester. It's got 4 problems on it. Number 1 is a review problem. I'm not going to go over it. I'm just going to show you my solution. You can pause the video and look it over if you want to, or you can try to do it yourself now. Okay. Number 2, I'm going to introduce this new issue, this new level of complication, and show you some stuff about manipulating equations with it. Okay. Number 3 is going to be another example of manipulating equations, and number 4 is going to be a chance for you to do it on your own. So if you want to open the PDF of this handout while you watch the video, that's fine. I'm going to go ahead and do each problem on its own as though it were on a blank piece of paper. So here's number 1. It's a system of 2 equations. Negative 4x plus 2y is equal to 2. 8x minus 2y is equal to negative 10. I'm not going to talk about it. I'm just going to post the answer right here, and you can review it if you like, or you can try to do it now yourself. So here you can see my solution. The important thing to note is that when I see this system of 2 equations, I recognize that if I were to add the left side of the blue equation to the left side of the top equation, I would get negative 4x plus 8x and positive 2y plus negative 2y. And the fact that these two are opposite signs with the same amount, positive 2 and negative 2, means that the 2y and the negative 2y will form a 0 pair and will eliminate the y variable from the equation. So you see that here. I add the top equation to the blue equation, and so I end up with negative 4x and positive 8x adding together for 4x, and 2y and negative 2y adding together to make 0. That gives me the one variable equation that I need to find one part of my solution, the x part of the solution to my system. And I use that x part of the solution to my system to solve for the y part. By plugging in x equals negative 2, I get myself another single variable equation. So I split off x, I solve it, and now I get y by itself in a single variable y equation. That allows me to find this solution here to the whole system. So it's really nice and convenient when you can just add together 2 equations like that and find that one of the variables is eliminated. However, as we'll see in number 2, we're not always so lucky. So we're going to go ahead and start problem number 2. Problem number 2 is a 2 equation, 2 variable linear system. The top equation is negative x minus 14y equals 3, and then the bottom equation is 10x plus 7y equals negative 30. Now I'm going to lead us on a little wild goose chase. I'm going to do something not very helpful just to make my point, okay? And I'm going to preview that point right now, all right? If you take a look at this top equation, if you add negative x plus 10x, you'll get 9x. And if you add negative 14y plus 7y, you'll get negative 7y. So if you just go adding together the top equation and the bottom equation, neither variable will be eliminated. And so we won't get that nice single variable equation that we need. If we subtracted, we did negative x minus 10x, we'd still get negative 11x, and negative 14y minus 7y would give us negative 21y. We still wouldn't eliminate either variable. So I'm going to go ahead and show that now off to the right. If you already understand what I'm saying, you can fast forward or just watch, just to convince yourself that, hey, look, if I add these 2 equations together, I'll get negative x minus 14y plus 10x plus 7y equals 3 plus negative 30, okay? And that gives me negative x plus 10x, and negative 14y plus 7y is equal to negative 27. And so my x's combine to make 9x, and my y's combine to make negative 7y, and I don't get rid of any variables, and so I don't have an equation with one variable that gets me any closer to solving my system. So this level of complexity requires us to do one more step in order to make elimination work here. Do something clever here. Okay? And I didn't come up with this, obviously, but I'm going to show you what mathematicians have figured out a way to combine these equations in order to eliminate one variable. And it looks like this, okay? I think to myself, all right, look, if I wanted to add negative x and 10x, those are pretty far apart. I'm not going to eliminate anything. But if I look at the y's here, if I could only get negative 14y and positive 14y to line up, then when I add those two equations together, the y's would eliminate. And so what I'm going to do is I'm going to take this bottom equation and I'm going to ask myself, okay, I want to have positive 14y there. That's what I want to be there, but it's not there. The way I could get it to be there is by doubling 7y, by multiplying it by 2. But I can't just double it. That'll change the equation. However, I do know that if I multiply the entire left side by 2 and the entire right side by 2, okay, if I do that, that will manipulate the whole equation. It'll change what it looks like, but it won't ruin my solution. So what I'm going to do is I'm going to take the entire left side, 10x plus 7y, and I'm going to multiply that entire thing by 2. And I'm going to take the entire right side, negative 30, and I'm going to multiply that entire thing by 2. And then I have to carefully use the distributive property to make sure that I multiply the entire left side, 10x and 7y, by 2. And on the right side I get negative 60. And so now I have 20x plus 14y is equal to negative 60. I've changed this blue equation. It doesn't look the same anymore, but I haven't ruined its solution because I did the same operation to the left side as I did to the right side. I did it very carefully. I multiplied the left and the right sides by 2. And so this new equation has a left-hand side and a right-hand side that look different and are now perfect for doing elimination. And I'll show you that now. I just take my top equation here, bring it down. Negative x minus 14y is equal to 3. I'm going to draw my little golden road, and now I'm going to add the same thing to the left side as I do to the right side. On the left side, I'm going to add the left side of the blue equation, 20x plus 14y, and on the right side of the blue equation, negative 60. And now when I go ahead and add these two equations together, I get negative x plus 20x and negative 14y plus positive 14y equals 3 plus negative 60. And so this is really wonderful because negative x and positive 20x give me positive 19x, and negative 14y and positive 14y are a zero pair, so the y's are eliminated, and I get now 19x is equal to negative 57. And I think that if I divide both sides by 19, I think that that's going to give me negative 3. So x equals negative 3. Okay? And if x equals negative 3, I'm just going to go back up to the top. I'm going to grab either one of the original equations that I started with. The top one seems a little bit easier. Negative x minus 14y equals 3. I'm going to replace x with negative 3. I have to be extremely careful here. Extremely careful because it's the negative of x, and if x is negative 3, then it's the negative of negative 3. The negative of negative 3 is positive 3 minus 14y equals 3. I'm going to subtract 3 from both sides and get negative 14y is equal to 0, and negative 14 will be multiplying by 0 there. So I get my solution, x equals negative 3, y equals 0. The important thing to recognize is that I want to add together these two equations and combine them, but if I do that, I'm not going to get either of these variables to eliminate, so I have to think of some clever move here that will get these two one of these variables to eliminate. And in this case, I just thought doubling 7y would line up negative 14y and positive 14y. And so I have to multiply the entire bottom equation by 2 double everything very carefully, giving me 20x, 14y, and negative 60 shown here. And that is that new layer of complexity. If you want to review the problem, pause it now. I'm going to do a second example, and I will leave number 4 for you to do. Number 3 will be my second example. I'm going to pull that off of my worksheet. So problem 3 is a system of two equations, and it is negative 5x plus 12y equals 13, and negative 3x plus 6y is equal to 3. Okay? I'm thinking to myself, if I add together my x's, they won't cancel out or eliminate. If I add together my y's, they won't cancel out or eliminate. But I can also see that if this 6y were instead of 6y a 12y, I could maybe cancel them out. And in fact, it'd be even easier if this 6y were a negative 12y. Because then I would have positive 12y plus negative 12y. So I have to think to myself, what do I multiply 6y by to create negative 12y? Okay, so I want to turn 6y into negative 12y. How do I do that? Well, I multiply 6y times negative 2 to get out negative 12y. So my entire bottom equation, negative 3x plus 6y is equal to 3. I'm going to have to multiply the left side. Do that in color. I'm going to have to multiply the left side by negative 2 and the right side by negative 2. And that way, by using the distributive property very carefully, I get negative 2 times negative 3x minus 2 times 6y is equal to negative 6. So I get positive 6x minus 12y is equal to negative 6. This new equation looks different than the one I started with here. But because I did the same operation to the left side and to the right side, I haven't ruined my solution. So now, if I want to pull my top equation down, negative 5x plus 12y is equal to 13, draw my golden road, and add the same thing to the left side as I do to the right side. So on the left side, I'm going to get 6x minus 12y. And on the right side, I'm going to get negative 6. So they look different, but they're equal. And I'm going to go ahead and add both of those things to the left and the right side. So I get negative 5x plus 6x, positive 12y minus 12y is equal to 13 plus negative 6. Negative 5x and positive 6x is x. Negative 12y and positive 12y is 0. And 13 and negative 6 make 7, so x is equal to 7. That's only part of my solution. In order to finish, I'll take either equation. Maybe this time I'll take the bottom equation, negative 3x plus 6y equals 3. I'll substitute in x equals 7. That gives me a single variable equation. Subtracting 21, adding 21 to both sides, I get 6y is equal to 24, and 6 times 4 will make 24, and so my answer in this case is I think that the solution to the system of equations is the ordered pair 7, 4. Okay? Number 4, I'll leave you to do yourself. So at any point in this video, you could have paused and gone back over it, but number 4 is for you to do yourself here. It's also available on PDF in the Google Classroom attachment, okay? And you have to look at this one and figure out what kind of manipulation you want to do to it to get one of your variables to eliminate, all right? You also have some practice on Khan Academy today. So here's problem number 1 if you want to pause and look it over. Problem number 2 if you want to pause and look it over. Problem number 3 if you want to pause and look it over, and problem number 4 is for you to do.